Hello everyone, I'm Shajib Ghosh. Today I'm going to present on my final project titled Lung Cancer Detection and Classification using Computer Tomography Images based on image processing and machine learning. I'm Shajib Ghosh. Now I'll be starting my presentation. So the presentation has been divided in 6 parts. In first part, I will talk about some key motivation behind this project. And secondly, I will talk about the problem statement and the possible solution to that problem. And thirdly, I will talk about some existing approaches and other research works related to this problem. In the fourth section, I will talk about the methodology of the whole process. After that, I will talk about the performances of different classifiers as well as the proposed method. Um, Finally, I will conclude and summarize the whole project and the outcomes and talk about some potential future works. Um, Lung cancer is the second leading cause of cancer according to the American Cancer Society, both in men and women. In 2021, it has been predicted that there will be around 235,000 new cases, among which men will be affected around 19,000 men will be diagnosed as a lung cancer patient, and another 116,000 women will be diagnosed as a lung cancer patient. It is, and also it has been found that it is the leading cause of cancer death. Around 25% of all the cancer deaths constitutes by this lung cancer. So far, though previously X-ray was used, chest X-ray was used for the diagnosis, but now it has been found that low-dose CT scans has been proved to be much more effective screening method. Um, Most of the cases, this lung cancer is not prevalent until a certain stage comes. So it is always a better idea and recommended to keep screening. Mostly the people who are older as well as the person who are addicted to smoking. So prevention is always offers the greatest opportunity to fight lung cancer. So whoever is a chain smoker or addicted to smoking, is a better idea to quit smoking now. Now I'll talk about the problem statement. So far, when there are large amounts of CT images, it is very difficult for the radiologist to determine cancerous nodules in the large number of CT images. So it is quite challenging for them. Also, it is time consuming, and also it has been found that according to the readers or the people who verifies whether there are cancerous or non-cancerous lung nodules, it has been found that there is some variability in the decision of the reader. So the decision is always error prone in most of the cases. So it will be always a better solution if this whole process can be automated, and it can be done, and the efforts and works have been explored and are being done by developing computer-aided diagnostic system, or CADX, by incorporating modern computer vision and artificial intelligence techniques. So now some existing approaches constitute that lung nodule segmentation using different segmentation algorithm, such as watershed algorithm, some thresholding technique. Those can actually help detecting those areas which are actually responsible or which are actually cancerous, or some cases which are not cancerous. Also, feature extraction is a very important step in case of lung cancer detection. It has been found that in 1997, Kawata and others have found that surface curvature and surrounding radiating structures have a very important notion while detecting the benign or malignant lung nodules. Also, in 1999, McNeil, Gray, and others developed a semi-automated contouring technique to extract the quantitative data related to the size, shape, texture, attenuation, and the distribution of attenuation of the lung CT images. So another step for the diagnosis of lung cancer is the lung cancer classification, and this can be done by incorporating artificial neural networks. And the first or the earliest neural network-based classifier was developed by Garnier and Swenson in 1995. After that, more progress has been done, and the modern systems actually includes automatic feature extraction and diagnosis using deep neural networks. As computational power has been more and more developed and improved. So in our cases, we have in my cases, I have followed this workflow. Like I have collected CT image data, then I actually worked on the image enhancement. After that, I worked on the image segmentation. Then I extracted the feature from the segmented image nodules. Then I have applied different different classifiers along with my proposed model. And then I worked on the model performance evaluation. So the data set I have used in this project is the Luna 16 CT scans, which constitute around 818 CT scans, and it has been collected from the Cancer Imaging Archive. So among these CT scans in that dataset, there was a folder which includes the segmented images of the segmented nodules. All this data has been converted into the hierarchical data format, HD5 data format, and then were used in the for training, validation, and testing purpose. So before going to the classification stage, there were some image processing and segmentation steps followed. I used a contrast enhancement to enhance the contrast and quality of the image. Also, also explored Canier's detection to see the ages of the nodules. Then explored watershed algorithm. This picture shows different steps of the watershed algorithm. It is the original image. After choose binary, it takes this form, and then I extracted the shear background, which black region actually shows the shear background, and the white region shows the shear foreground. So this is the distance transformed output. After that, I have extracted the thresholded output. Then I use the markers, which actually gives the watershed segmented output in here. So this is the final result after watershed segmentation, and it shows the different areas which has possibility to be considered as a cancerous nodule. Also, some key point detection techniques were explored, among which this is the Harris corner detection. This is the first key point detection technique, and this is the shift key point detection technique. Also, I have explored brisk algorithm to see the key points, important key points for the feature detection, and also the oriented shift and rotated brief method, the overview features. So after all the feature extraction, I have then applied some image processing while extracting features using the CNN architecture. So this is the downsampling part. Then the image was upsampled, and then I have got some image subtracted image. All these things, this processed image and was used for the feature extraction using the proposed CNN model. So this is the deep CNN architecture I developed, where the input segmented image was of shape 50 by 50, and there were there are two actually segment. One is for the feature extraction, and then one is the classification layer. These two actually form an um, end-to-end method for lung cancer classification. The feature extraction part, or the feature extraction segment, actually constitute around six blocks, where the first block uses the 2D convolution with a filter size of 32 and the kernel size of 3 by 3, and it uses the rectified linear unit activation function with batch normalization and max pooling 2 by 2, and the dropout was zero point 0.1. After that, the second block uses 2D convolution with the filter size of 64 and the kernel size of 3 by 3 with railway activation function and patch normalization. The max pooling was the same by the factor of 2, and the dropout was used of the value zero point 0.2. After that, the convolution layer used the filter size of 128, and the kernel was 3 by 3. It also uses the railway activation function and max pooling of 2, and uses the dropout of zero point 0.3. The subsequent two layers use dropout zero point 0.4 and zero point 0.5, but uses the same type of convolution with the same filter size and same kernel size. The last layer uses some dense layer, which uses the railway activation function and dropout of zero point 0.5, and there are three other layers with other dense layers with size 128, and the last layer was also a dense layer where actually the extractive feature was used for classification, and in here the softmax activation function was used. So the output is only two-dimensional, that is the binary classification, that is either it is cancerous or non-cancerous. After that, the classifiers I have used using the extractor features was subvector machine, XGBoost classifier, random forest classifier, k-nearest neighbors, and also my proposed CNN model. The evaluation matrix was used the precision, which is the ratio of true positives divided by true positive plus false positives, and recall was the true positives divided by true positives and false negatives, and F measure was the measure of the harmonic mean of precision and recall, and also I have measured the accuracy. So now I will show the different performance of the different approaches. So the classification performance of the trained model has been shown here, and I have applied I have analyzed the performance in different epoch values from ranging from 100 to 500, and it has been shown that the best accuracy was obtained for epoch number 100. Epoch 100, it shows the training and validation accuracy as well as the training and validation loss. So the highest accuracy was obtained at epoch 100, and the accuracy was around 96.12%, and this is the confusion matrix for this trained model. And the classification, it shows that around around 1318 were detected as benign, and 241 was detected as malignant. So there was around 1612 testing images, and this is the result for the this is the accuracy and loss curve for the epoch number 500. So after that, I have compared the performance of different classifiers which use the extracted feature of the CNN model at the last dense layer of the feature extraction stage. So it shows that XGBoost classifier actually had the highest training accuracy, but it did not perform very well in case of testing accuracy, in case of the testing dataset. For k-value 4, the k-NN classifier actually obtained the higher validation accuracy, the highest validation accuracy. Actually, the idea was to use different values of k ranging from 1 to 25, and and use that classifier which obtain the highest validation accuracy, and I use that k value for the testing purpose. And our proposed method actually outperformed all other classifiers with a testing accuracy of 96.12%. So to summarize the whole project, I have found that different image speed processing techniques actually enhance the model performances, and it is always recommended as the modern computer vision algorithms are more and more incorporating deep learning techniques and convolutional neural networks for large amount of CT image, computer tomography images. CNN should be the pri primary choice for automatic feature extraction. And the results I have found that are actually consistent with the other claimed results in earlier presentation and earlier research works. So our proposed deep CNN model actually outperform all other classifiers. So the advantage of this method is it requires time for training the algorithm, but once the trained model is obtained, it is fast and accurate in case of inferences. But as you know that there will be a speed accuracy trade-off always, and the training is a little bit time consuming. But the computational power, if we have the higher computational power and that setup, this training will take less time. And another thing with this CNNs are that it is really difficult to interpret the why a certain decision is made, as there are thousands of millions of parameters, and which node are important is difficult to actually explain. So in the future work, the integration of different self-explanatory feature will help us more visually understand and intuitively know that what actually CNN is doing and what has been done inside the CNN to get the importance of different features in case of detecting lung cancer. So this was all I had for this presentation, and then in the next part I will show the demonstration of the project. Thank you.